In this video, we're going to continue talking about solving triangles. Specifically, we're going to talk about solving triangles where you are told the lengths of two of the sides and you aren't told anything about the angles. So to figure out the length of the other side, you use the Pythagorean theorem, which of course is a squared plus b squared equals c squared, or you can think of it as leg squared plus leg squared equals hypotenuse squared. So let's say that your triangle has, the hypotenuse has length 5, and leg B has length 2, and you do not know the length of leg A. So we can use Pythagorean theorem here. We've got a squared plus b squared would be 2 squared equals c squared would be 5 squared. And of course, just always make sure that it's the hypotenuse squared that is over here by itself. So this is a squared plus 4 equals 25. We need a squared by itself, so subtract 4 from both sides. That gives you a squared equals 21. Take a square root, and we're going to go ahead and just round to the nearest tenth on this type of problem, unless it tells you otherwise. So I'm going to get a decimal here. It's about 4.6. So what about the angles? So in order to find the angles, you're going to use the inverse functions. Inverse sine, inverse cosine, inverse tangents, the one with the little -1 on them. And you can either do this for one of the angles and then subtract your answer from 90 degrees to get the other one, or you can do this process for both angles. Now the key on this is to remember that opposite and adjacent depend on which angle you are looking at. So you need to decide, am I trying to find angle A or am I trying to find angle B? Because if I try to find angle A, well, if I'm looking at angle A, then the 2 is adjacent. And the 5 is the hypotenuse. But if I were looking at angle B, well, that might be right next to A, but if I'm looking at B, 2 is no longer adjacent. 2 would be opposite to B. So you need to decide whether you're looking at A or whether you're looking at B. So I'm going to start with A. Let's look at A. And I am going to try to figure out how big angle A is. So instead of using the symbol theta like we did in the other example, we're just going to use the symbol A. So I know the adjacent side and I know the hypotenuse. Adjacent and hypotenuse, cosine, ka. I know that the cosine of angle A is 2 adjacent over 5 hypotenuse. So I need to tell my calculator, hey calculator, I've got this angle and its cosine is 2/5. Tell me how big the angle is. So the way I do that and figure out the measure of angle A is I tell my calculator to give me the inverse cosine of 2/5. Second cosine, 2/5. So I'm telling my calculator, tell me how big an angle is if its cosine is 2/5. And the calculator says, okay, the angle is 66.4 degrees. All right, so I've got a couple options to find angle B now. I could certainly say, okay, well, I know one of the angles, I know all three angles add to 180, and that one's 90, so these two have to add to 90. So I could certainly do this. Measure of angle B is 90 minus 66.4, which is 23.6, I believe. .6 degrees. And that certainly works. But I want to point out that there is another way that I could do this, and that is, let's stop focusing on A, and let's focus on B now. If I'm looking at B, well, the 2 isn't adjacent, the 2 is opposite. So I've got opposite and hypotenuse. Oh, opposite and hypotenuse, sine. So the sine of angle B is opposite over hypotenuse, 2/5. Hey, calculator, I have an angle and its sine is 2/5. Tell me how big it is. What's the inverse sine of 2/5? Oh, hey, look, it's 23.6 degrees. Same answer, different way of getting it. So you have choices. Now, personally, I think that one's a lot easier, but if you don't trust yourself on your first answer, you could certainly do the second way. And it doesn't matter as long as you're showing work and you're showing how you got there. So I'm going to do several examples of this type of problem. So again, the first thing I always do is fill in the things I know and label the missing side. So across from angle C is little c. And let's see, across from angle A is little a. So that 15 is little a. Across from angle B is little b. And we know that the right angle, the measure of angle C, is 90 degrees. Now, it doesn't really matter whether you find the angles or the third side first. I'm going to use Pythagorean theorem first. So I know that leg squared plus leg squared equals hypotenuse squared. 15 squared plus 13 squared equals c squared. So that's 225 plus 169 equals c squared. $394. Take a square root. And again, a decimal, whoops, wrong button. A decimal is fine on this. $19.8. And that is the longest side, so that's good because it's the hypotenuse. It's supposed to be the longest side. Now, to find the angles, you need to decide which angle you are finding, and it's a really good idea to circle it so you don't get opposite and adjacent mixed up. So I am going to find angle A first because I'm really unoriginal and I like to go in alphabetical order. So if I'm looking at angle A, 15 is opposite the angle A, and 13 is adjacent to angle A. Opposite, adjacent, TOA, tangent. So the tangent of angle A is opposite 15 over adjacent 13. Hey calculator, the tangent of angle A is 15/13. Tell me how big it is. Inverse tangent, 15/13. About 49.1 degrees. All right. The easiest way to find angle B would probably be subtract that from 90 degrees. And that would be 40.9 degrees. Just to point out though, there is another way I could have gotten angle B. I could have said, oh, let's focus on angle B. Well, if I do that, little b is opposite and little a is adjacent. Opposite and adjacent, it's still tangent, but the numbers switch because opposite is now 13 and adjacent is now 15. So the tangent of A and the tangent of B are just flipped. So the measure of angle B would just be the inverse tangent of 13/15. And if I did everything right, I should get 40.9. And look, I do. So you have choices. You could do both of them with inverse tangent. You could do one of them with inverse tangent and subtract from 90. You could have gotten angle A first. You could have gotten angle B first. Doesn't matter. You've got options here. All right, so this one, let's see. The unlabeled side would be little a. This 5 is across from angle B, so that's little b. And the 8.1 is across from the right angle, so that's little c, the hypotenuse. And the right angle is angle C, 90 degrees. All right, I'm going to go ahead and find the missing side first. So leg squared, a squared, plus leg squared, 5 squared, equals hypotenuse squared, 8.1 squared. So that's a squared plus 25 equals 65.61. Subtract 25 from both sides. That gives you a squared equals 40.61. Take a square root, and that gives you the A is about square root of the answer, about 6.4. All right, decide which angle you're going for first. Angle A or angle B. Circle it so you're not going to get confused. I'm going to go for angle A. 8.1 is the hypotenuse. 5, which is the side I'm going to use, is adjacent to angle A. Adjacent hypotenuse, cosine. So the cosine of angle A is adjacent 5 over hypotenuse 8.1. That means that the measure of angle A is the inverse cosine of 5 over 8.1, which is about 51.9 degrees. All right, let's look at angle B. So one easy way to get angle B is just do 90 minus 51.9, 38.1 degrees. Another way of getting angle B would have been saying, okay, I'm looking at angle B. 5 is opposite. Opposite and hypotenuse is sine. The sine of angle B is 5 over 8.1. So the measure of angle B is the inverse sine of 5 over 8.1. So if we did the problem right, we should get the same answer either way. Look, 38.1 degrees, same answer. You've got choices. Let's look at a couple where you have to draw the triangle. So the key is make sure you know whether the sides are 2 legs or one of the legs and the hypotenuse. So if you are told that B is 4 and C is 9, then you know that C has to be the hypotenuse. So it doesn't matter how you rotate it. Put a 9 there and a 4 here and call that A. It looks good to me. If you rotated it differently, that's fine. Just make sure that the hypotenuse is 9. So we know that little c is 9, little b is 4, and of course the measure of angle C is 90 degrees. I'm going to go ahead and find the other side first. So a squared plus the other leg squared is 4 squared equals hypotenuse squared. So a squared plus 16 equals 81. Subtract 16 from both sides. And you get that a squared is 65, I believe. Yep. Take a square root. We'll get something just a little bit higher than 8. Helps if you get the decimal version. About 8.1. Okay, decide which angle you're going to go for. So if I'm going to go for A, 4 is adjacent to angle A, and 9 is the hypotenuse. Adjacent and hypotenuse is cosine, ca. So the cosine of angle A is adjacent 4 over hypotenuse, 9. Which means the measure of angle A is the inverse cosine of 4/9. It's about 63.6 degrees. If I had been focusing on the other angle, if I'd been looking at B, 4 would be opposite to angle B, and opposite in hypotenuse, so that would have been sine of B would have been opposite 4 over hypotenuse, 9. So the measure of angle B would have been inverse sine of 4/9. 26.4 degrees. And hey, look, that's exactly the same thing I would have gotten if I had done 90 minus 63.6. Same answer. Last example here. We're told that A is 7 and B is 5. So those are the legs. So let's see, if that's A, then this is angle A across from the 7. And the 5 is B, so angle B is across from the 5. And the C is across from the right angle. So A was 7, B was 5, and the measure of angle C is 90 degrees. So we want to find the hypotenuse, so leg squared plus leg squared equals hypotenuse squared. It's 49 plus 25 equals C squared. And that's 74 equals C squared. C is about 8.6. If I'm looking at angle A, 7 is opposite to angle A, and 5 is adjacent to angle A. TOA. Tangent of A is 7/5, which means that the measure of angle A is inverse tangent of 7/5. About 54.5 degrees. And you have choices. You can subtract that from 90 to get 35.5 degrees. Or you could also switch the angle you're looking at, which also switches the opposite and adjacent. If you're focusing on B, I can't spell adjacent apparently, but if you're focusing on angle B, you still have tangent here, but now 5 is opposite and 7 is adjacent. So the tangent of B is 5/7. So the measure of angle B is inverse tangent of 5/7, which ought to get me 35.5. And it does. So again, it's up to you how you go about finding the angles, which one you do first. You choose. And it's up to you whether you do the angles or the side first. That is how you solve triangles.